The company 0x4447 builds products to increase standardization and security in AWS organizations. And they do this with automated pipelines that use well-structured projects to create secure, easy to maintain, and fail-tolerant solutions. One of those is their VPN product, built on top of the popular OpenVPN project, which has no license restrictions. You're only limited by the network card in the instance. To learn more, visit snark.cloud/deploy-and-go. That's snark.cloud/deploy-and-go, all one word.
Let's say you're deploying an application onto AWS. Very few applications are entirely self-contained. We've collectively built an ecosystem that's intertwined with dependencies between a variety of services and platforms. To communicate between them, your application invariably is going to need to store various credentials in some form. Usually, these are username, password pairs, or API keys. Let's further assume that you're not a dangerous lunatic who hard-codes these secrets into your application code. You want to find a way to maturely and sensibly store those secrets in ways that are centralized, so you don't have to update every server or container or function whenever one changes, secure, so they remain secret, and accessible. In practice, there's little difference between a service going down and you losing your credentials to talk to that service. There are a number of ways to do this with native AWS services that I'm going to divide into 3 categories: bullshit, reasonable, and controversial. There's a 4th category of using things outside of AWS, such as HashiCorp's excellent Vault product or another cloud provider's secret storage service. I'm considering things like that to be out of scope for what I want to talk about today. Let's begin with the bullshit options. At their heart, secrets are fundamentally key value pairs. I want to store something called root password and the value of the secret itself, such as kitty with an exclamation point at the end of it. You could use Route 53 text records, which is a fun gag, but seriously, do not do this, even if you like the chaotic energy of misusing a DNS service as a database. Security by obscurity is a bad plan when it comes to sensitive credentials. You might also be tempted to do something clever, like using resource tags within AWS. This is to be avoided. AWS doesn't consider tagging to be sensitive. It's metadata to them, which means that they're going to be treating it with a level of care you probably won't like. It'll show up in the AWS console, in logs, in billing files, in services like the little-known but greatly admired tag editor that you almost certainly haven't scoped access to, and so on. The AWS tagging documentation explicitly tells you not to do this in a scary red warning box. I promise you want to pay attention when AWS tells you not to do something. Now, AWS has 2 offerings that are explicitly aimed at solving this problem, and this is the reasonable category. The first is Systems Manager Parameter Store. Despite the extra words inherent in its name, like most of the Systems Manager subservices, it absolutely rocks. This is my go-to answer for managing secrets, specifically via its secure string parameter type. I either teach my code to make parameter store calls when it needs the relevant credential, or else I render it and deliver it to the container or Lambda function at deploy time as an environment variable. Both of these patterns have been approved by AWS in various ways. It has the added bonus of being completely free, at least until you get into whatever the hell advanced parameters are. Parameter Store has a couple of flaws, though. First, its rate limits are set rather low. 40 transactions per second may seem like a lot until you realize that in some scenarios, such as spinning up a whole bunch of jobs via AWS batch or kicking off a flurry of Lambda functions, could easily overwhelm that. Additionally, it has no support for cross-account access, nor does it have any inherent ability to replicate secrets between regions. If you want such things, you're building some scaffolding yourself to support it. AWS's answer to those flaws came in the form of AWS Secrets Manager, a top-level service aimed at this problem. Don't let people steer you otherwise. There is no inherent security downgrade if you use Parameter Store instead. Secrets Manager doesn't offer improved security directly. Instead, it offers a bunch of things you'd otherwise have to manage or build yourself. It automatically can invoke Lambda functions to rotate passwords for just about anything on-premise or off. It features native support for Redshift, RDS, and DocumentDB. It features native support for Redshift, RDS, and DocumentDB, which is Amazon Basics MongoDB, so you don't have to worry about rotating those secrets. And it sets a default quota of a whopping 5,000 transactions per second. It also features cross-region secret replication, easier audit trails without additional work on your part, and frankly, a way better name. I'm not joking about the name. It's super hard to see a service called Secrets Manager and not think that if you're using anything else to manage credentials that you're somehow doing it wrong.
This episode is sponsored in part by our friends at Vultr, spelled VULTR, because they're all about helping save money, including on things like, vowels. So what they do is they are a cloud provider that provides surprisingly high performance cloud compute at a price that, well, sure, they claim it is better than AWS's pricing, and when they say that, they mean that it's less money. Sure, I don't dispute that. But what I find interesting is that it's predictable. They tell you in advance on a monthly basis what it's going to cost. They have a bunch of advanced networking features. They have 19 global locations and scale things elastically, not to be confused with openly, which is apparently elastic and open. They can mean the same thing sometimes. They have had over 1 million users. Deployments take less than 60 seconds across 12 pre-selected operating systems, or if you're one of those nutters like me, you can bring your own ISO and install basically any operating system you want. Starting with pricing as low as $2.50 a month for Vultr Cloud Compute, they have plans for developers and businesses of all sizes except maybe Amazon, who stubbornly insists on having something of the scale on their own. But you don't have to take my word for it with an exclusive offer for you. Sign up today for free and receive $100 in credits to kick the tires and see for yourself. Get started at vultr.com/morningbrief. That's VULTR.com/morningbrief.
The big and arguably only downside to Secrets Manager is significant. Its cost. Secrets Manager charges a whopping 40 cents per secret per month. For context, that's more than it costs to store 17 gigabytes of data within S3 for the same time period. Additionally, it charges 5 cents per every 10,000 API calls. Combined with its ability to do 5,000 transactions per second, the numbers rapidly become rather terrifying. And of course, there's the controversial section as well, where given the API rate limits and lack of cross-region or cross-account access inherent to parameter store, and the frankly baffling economics of secret storage via Secrets Manager, I've had success leveraging storing secrets that are going to be accessed at high volume in either DynamoDB or S3, depending upon what your specific requirement is. This obviously isn't the first thing I'd reach for, and you'd have to build a bit of logic around things like versioning and rotation unless you want to chase a whole bunch of problems down. But now that both services support global replication and more favorable economics, it's certainly not a terrifying pattern at all. That said, yes, I know, it is clearly on the wrong side of the build versus buy debate, gives you a bunch of extra things to maintain for no direct value in return, and should really only be used at significant scale at a point where the other options I've highlighted become unacceptable for one reason or another. So fundamentally, there's not a bad path here short of the blatant irresponsibility of treating secrets as if they weren't sensitive in the first place. I think I've done a pretty good job of laying out how I think about managing secrets within AWS. If you think I've gotten it wrong, please reach out and let me know, because I'm positive there are edge cases that I haven't considered.
This has been a Humble Pod production. Stay humble.